This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level Maths Revision. In this video I'm looking at the AQA D2 specification, and it's question 5 from the June 2011 paper. The question starts off by telling us that we've got a network which is showing evacuation routes along corridors in a college from two areas in case of a fire alarm sounding. So the two rooms are A and G, and the exit is at X. So A and G on the left hand side of the diagram, X at the top right hand corner. It says the number on the edges represents the maximum number of people that can travel along the corridor in 1 minute. Well, the first part of the question, we're asked to find the value of the cut that's shown on the diagram, and then to work out the maximum flow along each of three particular routes, and enter them in a table which is given on the answer sheet. Following on from that, and starting with the answer that we've given in part B, we had to use the labelling procedure to find the maximum flow through a network, and it says that you should indicate clearly the flow augmenting paths that you use and the potential increases and decreases of the flow in the network. It then asks us to state the value of the maximum flow and to indicate a possible way of producing that flow on figure 4. The final part of the question is then just a little bit extra to that. It says during one particular fire drill there is an obstruction, which means that one point of the corridor is blocked to no more than 45 people per minute. So really, until we've done the rest of the question, that part is not going to make too much sense. Well, starting off then by looking at the value of the cut. Remember that the value of the cut is those arcs which go from the source set, so the left hand side of this cut as we look at, into the sink set, which is X. So it's going to include the 40, the 27 and the 24 that's there, but does not include the 6 in DE, which is going in the direction. So the cut value is equal to 40 plus 27 plus 24, which gives us a total of 91. If you want to give units, then that would be number of students per minute, or number of people per minute. And it's probably wise then to say that not ED, which is in the wrong direction, which is, we would say, which is out of the cut or away from X. The next part of the question just asks for the maximum flow along each of three routes. So A, B, DX. Looking at the top diagram, we can see that AB is 16, and then BD 16, and then DX is 27. So the maximum along that route then is given by the smallest of those values, which of course is equal to 16. If we look at GF BX, we've then got 19 there. And from F to B is 18, and from B to X is 40. So the smallest of those, 18, and that gives us the maximum flow along that route. GHEX, GH36, HE 24, and then 20, so the smallest route is 20. We're now going to transfer those flows onto the diagram using the labelling procedure. So remember that here we're going to have two arrows, one facing backwards and the other one facing forwards, and these will show the potential changes that there are in these flows. So if we look at AB, that one would be 0, we can't put any more than the 16, but we could reduce by 16 along that route. Likewise, from B to D, we could reduce it by 16, but we can't increase it because it has a capacity of 16. It then goes from D to X. Well, there is a potential to increase from the 16 up to a maximum of 27, so that gives us a potential 11 increase, and then looking backwards, that's 16. So that's the first one done. If we now go down to G and look at GFBX, where we've got 18, so from GF we could decrease by 18. It's got a capacity of 19, so there's a possible extra 1 going in that route. From F to B, obviously the 18 coming backwards, which is the actual flow. FB has got a capacity of 18, so that will be 0 in that one. And then along the top from B to X, there's a maximum of 40, so if we've got 18 going along there, we could actually have a possible increase of 22 and the decrease of 18, of course, coming back that way. So that's the flow of 18 along that second route. And finally, the bottom route from G to H, there's a capacity of 36 with a flow of 20 at the moment, so a possible increase of 16. The H to E is a capacity of 24, so a possible increase of 4, and coming back that flow of 20. And finally, from E to X, it's at full capacity, so that's a 0, but a possible decrease of 20. That's it for those three. There's nothing else flowing, so that's really achieved our initial aim of putting those onto the network with a labeling procedure. Right, now, well, clearly if we look at the diagram at the top right of the capacities, there's quite a lot that we can do with extra capacity. Certainly there's nothing yet going through C at this point here. So let's do those first of all. So going from G to C, we can add 7. So there's a route which goes G, C, C, B, and then from B to X. So let's put that one in first of all. G, C, B, X, and there is potential for another 7. So that will then saturate G to C. So in other words, we will have no more can go forward, but 7 can come backwards. So we're actually putting 7 along there. And likewise, on the next one, we have 7 coming back, but we have the potential to put 8 in that way. When it comes to BX, remember that it's the backward facing one which is going to increase, so that's going to go from 18 up to 25. The forward facing one, the potential increase is going to get less, so from 22 subtracting 7 gives us 15. There's another route going through C which is starting at A, so A, C, B, X, virtually the same route, this time with a total of 8, and that will saturate A to C. So that will give us no more can go through that once we put that 8 in there, and then you can see that that will then saturate CB, so that 8 will become 0 and 15. Finally at the top, that will give us a decrease from the 15 there to 7, and the 25 going up to 33. I beg your pardon, that increase, yes, from 15 to 7 is correct, so we've put an extra 8 through there. Well, at this stage it might be an idea to see where the blockages are, and you can see that we can't now go via C, and from A to B is blocked, so we can't come along here. So really we've got to go down now to G and start looking at the potential increases from G. Again, there are clearly very many different options. For example, we could go from G to H, F, D and X. So let's look at that in the top diagram. From G to H, we've got 16 that we can add in, 11 from H to F, F to D, 12, and from D to X, 11. So that gives us the potential for putting 11 through there. That's our smallest value increase. So if we do that, remember again that the forward facing is going to come down by 11 and the backward facing is going to go up, so that will be 31. Remember that those numbers there must always total up to the capacity, which it happens to be 36 for that route. This is now going to saturate H to F, so that's now a 0 with 11 coming backwards. From F to D it has a capacity of 12, so they've still got the potential of putting an extra 1 there, and then that 11 coming backwards. And finally we're going from D to X with a value of 11, so that will come down to 0 now increase possible, and 27 there. So there's another route which has been saturated. We haven't used E to D yet, and that's got a potential for putting 6 down there. So if we work from G, GH is 5, HE is 4, ED 6, and then we could go from D to B to X. So we've got this route now which goes along DB, this route here. It's actually changing the flow, so ignore the direction of the flow here. Look at this one here, and you can see that the arrow is facing forward. So the route I'm going to use, I will highlight, sorry, I beg your pardon, that's gone off the wrong page there. I'll put a highlight in a second. So I'm going to go from G to H, and then from H to E, then E to D, and then this is the crucial one really, from D to B, and then along here from B to X. And we can see that the smallest value on there is from H to E, which is 4. So writing that out, then I've got G, H, E, D, B, X. So adjusting that by 4 means that that is now 1, and backwards 35. This is now saturated here, and this becomes 24. This route has still got the potential to increase by a value of 2, but it's coming backwards here by 4. That number is changing from 16 to 12, and then from 0 to 4, and then finally the 7 at the top there is changing to 3, and the 33 to 37. Right, most things are blocked, but there is one more route which is available to us. This one again uses a reverse flow along BD, so it's going to come this one here from G to F, F to D, and then D to B, and finally B to X. So remember, as long as those arrows facing towards X are positive, we can use that. The smallest is 1, so we can increase by a further 1 unit. And the path I'm going to use is G, F, D, B, X by 1 unit. And that will finally change us to 0 and 19 on that one, 0 and 12. That's going to be 11 and 5, and finally 2 and 38. Right, there we are. Quite a complex question that to achieve that total. If you add all these flows up now, the flows that we started with plus the extras that have gone in there, we get a total flow of 85. Now the marking for that, there were 3 marks available for showing the flows initially, just a mark each. So they were scored at B1, B1 and B1. Then there were method marks and A marks in here for getting the correct flow augmenting path. So in a total of 5 in there. Sorry, there were 4 there and then 1 for the final total. Right, we're asked to show the flow on this final network. We've actually already worked out that the maximum flow was 85. The flow is given by the backward facing arrow. So for example, the flow in AC is 8. If we do GC is 7. So working along the top there, AB is 16. From BX we can see that it is 38. That's the final value that we've got, that part. I'm just going through these now one at a time. 15, 8, 11, and then going from G to F we've got 19. F to D is 12. D to X is 27. E to X 20. There's 4 from E to D. The E to D, remember, it's that 4 there. H to E 24 and H to F 11. I think that's all of them. Just a quick look round, just make sure that you have got those values being consistent. Oh, I've missed one out, probably the one at the bottom. GH is 35. So for example, the 35 I just put on there, GH, then splits 11 and 24, which does make sense. And if we look perhaps at E, for example, there's 24 going in there, and that splits 4 and 20. So your junction should be consistent. The final part of the question says that we have an obstruction, and the obstruction is taking place at vertex B. Well, we can see that at the moment going into B there's a total of 16 plus 15 plus 18. And 16 plus 15 plus 18, these ones here, the 16, the 15 and the 18, giving us a total of 49. So if we have a restriction there, which means that we can only put 45 through, then the difference between those is 4. So in other words, there's 4 fewer through that junction, and hence the total is, or the maximum flow is now 81 per minute. There were just a couple of marks for that. Method mark, M1, and an A mark. Well, that's the end of that particular question. You can find videos looking at other questions and information as well about A-level mathematics at www.furthermaths.org.uk.